dear students, welcome to the new session. We were studying force, work, power and energy. In our previous session, we discussed about moment of force, about torque. In this session, we will discuss some more terms related to this particular topic. So let's start today's session. So first of all, we will discuss about couple. So what is this couple? Couple, as you know, that it's a force. When we apply some force on any object, then if the object is not pivoted, if it is not fixed, then it will do the translational motion. And if it is fixed at any point, then it will do rotational motion. But do you know that with one point fixed, if we are applying force from one side only, then it requires a lot of force to be applied to rotate any object. We can rotate an object very easily if we will apply force in both sides. Suppose that this is any body or object, okay, and it is fixed at this particular point. Now we are applying force at this side. It will do anti-clockwise rotation, right? It will do the anti-clockwise rotation. But this force is extremely large. You know, it will require approx 10 Newton. Suppose that it requires approx 10 Newton of force to rotate this body in anti-clockwise direction. What I said, that rotation can be done very easily if we will apply force on both sides of this body. If we will apply force on both sides of this body. Right now too we are applying the force on both sides, but one side's force is passing through this pivoted point. In every case, whenever there is a rotation, the two forces must be applied. In this case too, two forces are applied, but one force is passing through the pivoted point. That's why its perpendicular distance will be 0. So it is not considered. So it is not considered here. But take another case. Suppose that this is fixed at this particular point. Now you are applying force in this direction, right? And another force is being applied in this direction, right? Now this force is not passing from the pivoted point. Earlier it was passing through the pivoted point, but right now it is not passing through the pivoted point. It is having some distance from this fixed point or fulcrum. We call it fulcrum, okay? So now two opposite forces which are equal in magnitude are applied. Hence, rotation can be done very easily. Earlier, this was 10 Newton. Now, it must be of 5 Newton or much lesser than this too. It can be of 2 Newton and it will be rotated. I hope that you got. Whenever we apply some external force on any body or object, if the body is pivoted, it will do the rotational motion, but it requires a lot of magnitude of the force. Means large force will be required to rotate the object. But if we will apply a reaction force opposite in the direction, then rotation can be done very easily. This reaction force which is applied against the external force, when the both forces will be considered, it will become a couple. It will become a couple force. So as you can see here, there are many examples of couple force. One of the example is of tab. When we open any tab or close any tab, we apply force from both sides. This finger, this forefinger will be applied in this direction, and this thumb will apply force in this direction. So two equal and opposite forces. The forces are equal and opposite in direction. Right? When two equal and opposite forces will be applied on any body, these forces, the combination of these forces will be known as couple force. As in this case, one force is applied in this direction, another force is applied in this direction, and both forces are equal in amount. Hence, the combination of this force will be known as couple force. What are the conditions? The conditions are that the direction of these two forces should be opposite to each other, and the amount of these forces, magnitude of these forces should be equal. Right? Magnitude of the forces should be equal and the direction of the forces should be opposite to each other. And the third very important point, that it should not pass through the pivoted point. Its line of action should be different. Right? So these are some of the points which should be considered while explaining the couple force. Once again, I am repeating what are the main points related to the couple force is that the couple force, the direction of both forces should be different from each other, and the line of action of force will be different, and it should be different. It should not pass through the fixed point or fulcrum or pivoted point or axis. These forces should not pass through axis, right? And it should be equal in magnitude. So when these forces are applied on any object, these forces are known as couple force. So we can write down the definition of couple force: when two equal and opposite forces applied on any object, then object will rotate and the forces will be known as, and the combination of these forces will be known as couple force. And important point is that couple force should not be, in couple forces should not pass through pivoted point. Right. So this is all about couple force. I hope that now you will be very aware with couple force, and in your daily life you must have experienced this force. Whenever you are opening your bottle cap, you apply the same force, which is known as couple force. Okay, so moving on next. Moment of couple. So what is moment of couple? Couple means two equal and opposite forces parallel to each other. Okay. So here two forces are applied which are equal and opposite. F. Both forces will do the anti-clockwise rotation. Anti-clockwise rotation. Okay. So moment of couple, suppose that this force is F1, this force is F2, and this distance is D, this is D, right? So moment of force, what will be moment of force? This point is A, this point is B. Force at point A, moment of force at point A. F1 is equal to how much? Here it is F2. Moment of force at point A is equal to F2 into D or D1, right? And this is D2. And M moment of force at point B is equal to F1 into D2. So total moment of couple, total moment of couple is equal to F1 into D2 plus F2 into D1, right? If F1 and F2 are equal in magnitude, then F into D1 plus D2, right? So this is total moment of couple. It will be, both will be anti-clockwise, this will be anti-clockwise and this will be also anti-clockwise, right? So both forces will be anti-clockwise. So this moment of couple will be the moment of force about A plus moment of force about B. That will be the total moment of couple. Okay, moving on next. Equilibrium and its types. So what is equilibrium? You must have studied about the equilibrium. Suppose that you have studied in your class 9th about the heat. You have studied heat, okay? If two bodies are having unequal temperature, suppose that this is very cold and this is very hot. If we will touch both of these bodies, then after some time you will realize that both are having the same temperature now. And in the condition when both will have the same temperature, they will be known in equilibrium state, right? So equilibrium means now all the forces which are acting on any body will make a condition that the body will remain in its original position. If it is in rest, it will remain in rest, though there are many number of forces are acting on this. And if it is moving, it will continue moving, though there are many forces are acting on this body. Means object will remain in its original position, in whichever position it was, though there are many forces are acting on this, if the body is in state of equilibrium. If more than two, suppose that here I took this seesaw and there are many forces acting on it. This is one force, this is another force, this is another force, right? And here too many forces are acting, right? Earlier it was balanced. This was first case when it was balanced. It was in position of rest. Now we applied some force at this side, at A side as well as B side. It is not necessary that this force should be equal to this or this should be equal to this, but the total moment of force at point B should be equal to total moment of force at point A. In this condition, this will remain in the state of equilibrium. So we can say if two or more than two forces are acting on any body, but total moment of force remains 0. Or what we can say? We can say that algebraic sum of moment of force. If two or more than two forces are acting on any body, but total moment of force remains 0, or we can say that algebraic sum of moment of force is 0, then the body will remain in equilibrium state. Then the body will be in state of equilibrium. It will be in a state of equilibrium. What does it means? The algebraic sum of this side's forces is equal to the algebraic sum of this side's forces. So in this condition, I will be in a state of equilibrium. Same happens when the body is fixed at any point, and at both sides of this fixed point, if equal and opposite forces are applied, then body will remain in state of equilibrium. If it is not fixed, in that case, if the body is not fixed, suppose that it is in motion, it is not in the state of rest, it is in state of motion, will then the equilibrium condition will be, in that case, can we get the equilibrium position? So there are two types of equilibrium. As I wrote here, it's types. So there are two types of equilibrium. One is static equilibrium and another is dynamic equilibrium. First one is static equilibrium and another is dynamic equilibrium. In this case, if the body is in rest, if the body is in state of rest, it will remain in same state. Right. In a static equilibrium, though there are many forces are acting on the body, but the algebraic sum of all the forces is equal to 0. What does it means? The net force acting on the body is 0. Hence, the body will remain in its original state, in whichever state it was. Now, the second one is dynamic equilibrium. Dynamic equilibrium. What is dynamic equilibrium? If the body is in a state of motion, if the body is in a state of motion and some forces are applied on this body, if the body is in a state of motion, if the body or object is in state of motion, it will remain in the state of motion if algebraic sum of all forces applied on it are 0. Right. So these are two type of equilibrium states. One is a static equilibrium. As I said that I am in a state of rest. Some of my friends are pushing me towards themselves, but I am in a state of rest. So I am in a state of static equilibrium. Now another case, it is raining. So raindrops are in the state of motion. Now the force due to gravity is applying on this raindrop, right? Suppose that this is a raindrop and the force of gravity is applying on this raindrop. If equal and opposite force will be applied on this raindrop, then it will be in a state of equilibrium. So the friction of air, and upthrust, these are the two forces which will be applied on this raindrop in opposite direction. Both forces will be cancelled since they are equal and opposite. So net force on this raindrop will be 0 and it will be in dynamic equilibrium state. Why? Because it will be in constant velocity state. It will have constant velocity. There is no acceleration, right? So it will get constant velocity. Since both the forces or all the forces which are acting on this raindrop cancel each other. Why cancel each other? Because they are equal and opposite. As I said that gravity is acting in downward direction while upthrust and friction of air is acting in upward direction. Hence both of the forces are equal and opposite. So they will cancel each other. In this case, this raindrop will be in the state of dynamic equilibrium. It will have the constant velocity now. So these are two types of equilibrium states. Now moving on next, principle of moments. So principle of moments, what does it says? Suppose that I took an example, right? Now, moment of force at A, at point A, what will be F1 into R1, right? And what will be its direction? Right, this. It is clockwise direction. Clockwise. And moment of force at point B is equal to F2 into R2, and it will be into the direction of this anti-clockwise. Anti-clockwise. So principle of moment says clockwise moment of force is equal to anti-clockwise moment of force. Right. This is what principle of moments. Clockwise moment is equal to anti-clockwise moment. Yeah, moment of force, or you can say. So this is principle of moment. Okay, so moving on next, here is the question on the basis of principle of moment of force. What does it says? In the figure given below, a roller of diameter 0.5 meter is raised on the pavement XY by the forces F1 and F2, each of magnitude 10 Newton. Compare the torque produced by the two forces. So two forces are acting here, as you can see. One force F1 is in this direction. It is trying to rotate it, producing some torque in this direction. So this is line of action of force. Okay. Take a straight line. This is line of action of force. And another force is this, F1. And its line of action of force is this. Right? And it will be the pivoted point. Here, this roller will roll here. Okay? This roller will roll here. So now, what will be torque produced by F1? Torque produced by F1. Suppose that this is tau 1. Tau 1 is equal to F1 into this much of distance, perpendicular distance, D. And how much is this? The diameter is given here, 0.4 meter. So this distance is 0.4 meter. Right. Tau 1 is equal to F1 into D, and it is equal to 10 Newton. Forces are of 10 Newton multiplied by distance, perpendicular distance, which is 0.4 meter. So tau 1 is equal to 4 Newton meter. Okay. Now, what will be the torque produced by F2? Torque produced by F2. Tau 2 is equal to F2 into perpendicular distance. What is the perpendicular distance? This much. And it will be equal to this. So this is radius of this roller, and it will be equal to 0.4 by 2, 0.2 meter. Right. So perpendicular distance is 0.2 meter. Force is 10 Newton into 0.2 is equal to 2 Newton meter. Now compare these two. Tau 1 upon tau 2 is equal to 4 by 2 is equal to 2 ones are 2, 2 twos are 4, 2 ratio 1. So this will be the ratio. Okay, 2 ratio 1. Now the next question. So here is the question. The beam shown in the figure is 2 meter long and has a weight of 20 Newton. It is pivoted as shown. Two forces of 20 Newton and 10 Newton are acting on it as shown in the figure. One is 20 Newton force is acting and another 10 Newton force is acting here as shown in the figure. Are acting on it as shown in the what force F must be applied downwards at the other end to balance the beam. So it is asked what will be the value of this force. So by principle of moment of force, what we will apply? By principle of moment of force, anti-clockwise moment of force should be equal to clockwise moment of force. Right. So at this side, how many forces are acting? F is acting. What will be the value of F? We have to calculate. So F into perpendicular distance is 0.5 meter from pivoted point. This is pivoted point to 0.5 is equal to, at this side how many forces are acting? One force is acting at 0.5 meter and another force is acting at 1 plus 0.5 at 1.5 meter. Okay. So the two forces are acting at this side. So 20 into 0.5 plus 10 into 1.5, 1 plus 0.5, 1.5. Okay. So what will be the result? F into 0.5 is equal to 10 plus 15. 10 plus 15. So F into 0.5 is equal to 25. So F is equal to 25 upon 0.5. So F is equal to 50 Newton. So this will be answer. Means this force should be of 50 Newton to balance it, so that it came into the state of equilibrium. This force must be required. Got it? Okay, moving on next slide. So that's all for today's session. At the end of the session, there is a quote for you: be alone, and that is the secret of invention. Be alone, that is when ideas are born. It is very true. You must have heard that saints or your elders must told you that you have to do the meditation. What is the reason for meditation? You comes into the state of being alone, into the state of being alone. Or you can say that inventions, ideas, all are born when you meditate. In the state of meditation, what you does? You are in a state of being silence, being free from all the work headache, whatever the happening in your mind. You being free from all those problems, complications. When you are meditating, then only the ideas will be born in your mind. So that is what written here. Be alone, that is the secret of invention. If you will be free from other problems, then only you will be able to do the invention. Be alone, that is when ideas are born. So it is very true. And it is said by Nikola Tesla, one of the greatest scientists who invented alternating current. Okay, with this quote, now I would like to wind up this session over here. We'll meet in the next session. Till then, take care of yourself. Have a great time. Thank you for watching this session.